Hi everyone, thanks for coming along. My name's Don. I'm the designer of the F# programming language. I've been a contributor to .NET over the years, to C# as well, C# 2.0, C# generics that a lot of you use. And I'm here today, I'm very happy to be here to talk about the world from the language designer's perspective. You've had, I think, a really wonderful selection of talks on the functional programming track. Some of them have been F# talks. We've had talks about more general things. I think Michael Newton, have you given your talk yet? Where's Michael? Is he here? He's not here. He's giving a talk on a wonderful set of testing methodologies called FS-check, which can be used with both C# and F# code. And you've heard from Philip yesterday about why you should use F#, why you should make the switch to functional programming. So I'm not here to sell F#. I'll be talking a little bit about why F#'s been successful and why you can, some examples of what makes it great. But I want to give you more a perspective of the world from the language designer's point of view. And it's a talk about language designers are strange people. Okay, part of this point of this talk is so you can understand where language designers are coming from, so that when you go and talk to Mads Torgerson, when you go and talk to me, when you get responses from us on FS Lang suggestions, when you give input, you understand why we're kind of all twisted and contorted and kind of like, oh yeah, think about this, or I might think about that, or they're trying to weigh things up and balance things and synthesize things and put lots of different perspectives together. Because when you're a language designer, you got like F#, tens of thousands of people using your thing, and you get input from an awful lot of them. And you get a lot of input from them. When we first decided to productize F#, it was about the same time that Scala was, my good friend Martin Nadersky was also working through Scala releases. And I wrote to him and said, we're going to have a lot of feedback on this thing, aren't we? And he wrote back saying, yep, it's going to be there's going to be a lot of stuff coming in, and we're going to get a lot of influences coming in. Mads, of course, with C# has hundreds and hundreds of thousands of people sitting on top and using C#, and they get an awful lot of input on that as well. So what that all adds up to, when you have so many different perspectives and so many different influences, is you're in a sense exposed to the great disputes of the area of work that you live in. So, for instance, you might be exposed to the disputes between, let's just take one of the really big ones that I'll be talking about today, between functional and object-oriented programming. These entirely different streams of intellectual thought, of academic research, of application, flow up and through the lives and all through the different perspectives and people that come in and that come down in the feedback you get and the influences you get from all sorts of different perspectives. And you're exposed to these disputes that we have. And so really sort of the starting position of the life of many people working in these core tooling areas. The same applies in many ways to people working on virtual machine design. When you design a virtual machine, you've got that same set of different traditions and different ideas coming in. And in the end, you've got to synthesize that. And you've got to make something that makes the world a better place, and in many ways it has to contribute. And the primary sort of message of this talk is that the act of making a contribution in this core sort of space is an act of synthesis and an act of resolving, working out a new direction between out of what seem like conflicting points of view. So these disputes of computer science are a starting point. And the act of making the resolution, of coming out with a new language, a new product, should actually make the world a simpler place. It should make the world a more relaxed place. It should make the world a place that's more productive, yes, but it should be a resolution of disputes. Now, this, of course, is not a great idea, not a new idea. It's an old idea. It goes right back to this wonderful guy. Anyone who knows who this is? Hands up, anyone? I know Thomas does. He's in the audience. So this is a philosopher called Hegel from the 1830s. Incredibly influential philosopher who, one of his very core sort of fundamental ideas about human life is that progress is through the resolution of this, what they call dialectic between this an idea and the opposite idea, and the contradictions that come. And change is not through fighting between these ideas, but change comes through synthesis of opposing points of view in a new direction that wasn't anticipated. So has anyone ever read any Hegel? Anyone ever done that? It's absolutely impossible. I mean, it is so unbelievably difficult. Anybody here from Baden-Württemberg? Anybody here from Germany? Okay, anybody here from Baden-Württemberg, from Schwabia? Okay, well, I've been told on good information from my wife that only people from the Stuttgart area of Germany can actually understand Hegel because he wrote in a dialect of German. So that's probably why no one understands him. But he is an incredibly influential philosopher based around this idea of synthesis and change. Just to say that this idea of synthesis out of opposites it's a very powerful idea. I love the idea. But of course, like all things, you can take it too far. One great thing that demonstrates this is this wonderful spoof paper that Thomas Petracek pointed me to. I think Thomas is standing over there with his baby. He said, "Oh, you're talking about dialectics. You're talking about resolution out of conflict and opposites. You mean mustard watches." Here we go, mustard watches, an integrated approach to time and food. So, time and food, I mean, they're clearly, opposites, and we need to find a resolution between these contradictory ideas. And so this is one of the very first examples of sort of taking the mickey out of philosophical positions and just saying, yeah, we can take these too far. We can't resolve all conflicts and differences in the world. Some things are truly orthogonal and should be just left orthogonal. So hopefully we're not doing this. Hopefully we're not just kind of making the mustard watch, but we're actually making real progress. So for the rest of the talk, I'm going to be talking about both technical and sort of sociological things that come up in our work as language designers and as tool deliverers. And I'll be talking about things that are in conflict, in sort of opposites, and talking about how we can find some synthesis between the two. And that's all going to be in the context of my work as the F# language designer and as the deliverer of tools to the computing world. Okay, so I'll start with the conflict here that's really was the root of F#. This is what F# was about, and in many ways it's what .NET was about. Right back, the very founding spirit of .NET was we're going to have a virtual machine, but it's not going to be like Java, which at the time had a very weak interoperability story. It had a very weak multi-language story. We're going to have a virtual machine that supports multiple programming paradigms, and it is going to be able to interop extremely well with COM, with C, and then ultimately I think .NET has an exceptionally good interoperability story with a whole range of things. And this is an ongoing theme for .NET itself in the interoperability sphere. You'll see a lot of the tooling that gets built in the .NET area is about solving the interop sort of dilemma and making sure that the tool plays well with other tools. But for me, I was a functional programmer, and I landed at Microsoft, and I landed at the start of .NET, and I was a researcher as well, and I absolutely loved a certain kind of functional programming. I'd been strongly influenced by the OCaml language, but I'd worked in a whole range of other languages. But I knew there were big problems over in the functional world. And if we remember back to that time, the time, roughly speaking, 2002, 2003, these functional languages that we had then, they were really very isolated, and they were isolated for reasons, okay? They were isolated. If you look at a language like OCaml, absolutely fantastic language, absolutely fantastic virtual machine, and runtime infrastructure, But because they had their own virtual machine, then it was just difficult for them to interoperate. It had a good C interoperability. It was okay, C calls. But other languages, like the Mirandas or the Haskells and others, also had severe interoperability problems. They were isolated, non-interoperable, and using their own virtual machines. And back in the day, some of you will remember, what was interop like then? Well, it was C calls. We still use those. That's fine. Com still gets used a bit. Corba. Anyone using Corba? Anyone? Oh, no. You're the one. I'm sorry. There's always one. I'm sorry. I'm so sorry. Is it only one? Was there anybody else? No. I don't even know what Corba actually did or does, but it was what interoperability, the big thing of interoperability back then. Lots and lots of XML, of course, was the big rage for how everything was going to interoperate. We still use that a bit. But from the point of view of functional programming, it says these things here don't get us what we need, which is a rich ecosystem of libraries and components to be able to and even these functional VMs had to design their own interoperability mechanisms. It was a mess. It was a bad situation, and it meant that there was a real contradiction in practice between using functional programming and using the modern virtual machines. Okay, so the F# approach, it was seen as crazy at the time. I mean, I know it's so normal now. Of course people make these languages, Scala, Swift, Kotlin, and there's a whole lot of others, all use the same fundamental approach that F# took. Perhaps I'll also call out a language called MLJ, which was a predecessor to F# in many ways, as bringing the standard ML language to the JVM back in the late 90s, where some of my colleagues at Microsoft Research also took this approach. And it was seen. People said, look, there's no way you're going to get a functional language that runs anywhere near fast enough by running on an object-oriented virtual machine. They were just absolutely dismissive that this idea of taking functional programming and sticking it on .NET was going to work out in practice. And it has worked out. I mean, we were absolutely right. The Scala people were absolutely right as well to take the programming paradigm, a slightly different emphasis in Scala, but in F# we're taking this functional first programming paradigm. We're sticking it on top of .NET, an industry standard runtime layer. And now, the act of doing that is not just making, say, OCaml.net and then sticking rigidly, this is what OCaml is, and this is what .NET is, because that doesn't give you the win-win that you need between in the ecosystem that you're in. Just like Scala wasn't just taking some existing language, we really do let the environment, the exoskeleton sort of environment that you're walking into, influence the language design to some degree, to an appropriate degree. We have to keep the exosystem at an appropriate distance. So there's really a balancing act as you, I think my clicker's gone. There might be another one here. I might have to, yeah, here we go. Does this still work? Oh, it does. Okay, great. So there's a balancing act that you have to do as you make a language design situated in the .NET ecosystem. And in particular, you have to design the language with interoperability in mind, and that runs all the way through the F# language design. We do care about interoperating with C# and interoperating with .NET DLLs and interoperating more widely as well. And I'll talk about that when we talk about type providers as well. And we do need to compromise some elements where needed. If some elements of the approach that, the functional approach don't fit on the platform, aren't useful on the platform, then we won't do it on the platform. Okay, so this tension here, we have this sort of new direction, an arrow going down, which is functional on interoperable virtual machines. And it has worked absolutely fantastically. As I said, it's not just an approach used by F#. When you look at the Kotlin language design situating in the context of the Android, well, both generally, but in particular the JVM and the Android ecosystem. If you look at the Swift language design and the Objective-C ecosystem, those languages are very much following this kind of path that has been trodden. So that's definitely a story in relaxation. I don't wake up anymore like I did in 2003 saying, I really want to be able to have a functional language that runs on .NET. I really want to be able to use functional programming in practice because I can. Okay, that I don't have to worry about that anymore. That problem is solved, and life is pina colada time, relaxation. So these, and we haven't given the baby away. These functional programming languages are true to their principles, I think, and so that's certainly true for F#. So Scala has a slightly different set of design principles, but they, I think it stays true to the true to a mixed functional object-oriented paradigm. And I'll talk about F# type providers in a bit. Okay, but I do want to say that there are some things we don't do in F#, partly because they're not easily implemented on industry standard virtual machines. There's a feature called higher kind of types, which is both, there's also a feature called type classes. They're both functional language, functional techniques, and we don't do them in F#. That's partly because of implementation issues, and partly because, well, then in that context of an interoperable context, they're not as useful as they are if you've got control over the whole library design. So because we don't have control over the whole .NET library design, then it's not really quite as compelling to do those features, and in fact, it could actually be a negative in some situations. All right, okay, so that's a technical feature, functional and interop. I now want to turn to a more sociological kind of thing, which is this massive tension as a tool deliverer and as a person creating a language and working with a community and with an ecosystem. And it's a tension which many of you have in your working life as you work in enterprises and you consider how to relate to open source. And that's this big tension between enterprise and openness. And funnily enough, I don't think we really have a name for what the resolution of this thing is. It'd be interesting to try and think of a term. We say Microsoft's embraced open source is open source, but we absolutely haven't given the enterprise thing away. We've created, and other enterprises are doing the same thing. We've created something else that's in the middle that we need a name for to say what's this thing that you get when you combine enterprise and openness and in a positive synthesis and combination. So I'll just talk about where we are now. I think Philip and others have covered this really, really well. F# as a language design has what I think of as a sort of a demilitarized zone called the F# Software Foundation, and it has this kind of space which is neutral and independent. It's cross-platform, neutral, and independent. And that means there's sort of, although F# is heavily influenced by .NET, it also is used on JavaScript extensively. And it's also, although F# has great tooling in Visual Studio, we also have other contributors like JetBrains who make professional tooling for F#. And what it means is everybody involved in F# agrees that there's this sort of space where we consider things from a neutral, cross-platform and independent point of view. And that certainly applies to the F# language design. And it also applies to many other aspects about how F# works as an ecosystem. Of course, we're open. I think nearly all F# tooling all of it is accepting contributions and is licensed under good licensing terms. And I mentioned F# org already as part of this cross-platform, neutral and independent. This gives the community a very strong voice in the F# arena. The community can have a route by which to shape what the F# ecosystem looks like, both from a technical and a social point of view. And so that's through the F# Software Foundation, which is an absolutely wonderful thing. On tooling, I work for a group called Microsoft Mobile Tools, and we sort of do .NET for devices, which we can also call Xamarin. And we provide F# tools for Android and iOS. I spend a lot of my time working out new programming models for doing app programming and sitting there with my Android device happily, sort of getting the apps to do their thing. I'll be talking a bit about that later. we have the Visual F# tools and Microsoft tools for Windows and Azure. I've also mentioned JetBrains and other tooling providers here. And of course, we have this this wonderful story for F# for .NET Core, which means we have a great story on Linux and OS X and everywhere where .NET Core runs, and also on multiple cloud platforms. We have Google Cloud Platform support for F# through .NET Core. We have Amazon Lambda support for F#, and so on. And that's largely coming through the fact that F# is part of .NET Core. Okay, so underneath this, at a technical level, a lot of this is driven through this one component called the F# compiler service. It drives the Xamarin tooling, it drives the Visual F# tooling. It's the core of the compiler that's delivered through .NET Core, but it also drives a lot of other scenarios. That's a fully open component. It also drives a thing called Fable. It's just a DLL, a single DLL, F# compiler service.dll that gets included into all these different components. When we make an addition to the F# language design, we're really making an addition to this component, and then out it flows into all the different tooling. Okay, so a very integrated, cohesive tooling story where we're able to make change here and flow it out into a whole range of different packaging and tooling delivery channels. So we have this wonderful thing called SafeStack as well. I'll talk about that in a bit. And what all of this means, okay, and it's been taken us a real journey to get to this point for F#. And what all of this means is the enterprise story is resolved, the openness story is resolved. Whatever we call this situation where we have this combination is a relaxing, super relaxing situation for me. In that I get to concentrate on my part of the game as language designer down here. I've been using this slide for a couple of years, and that number there has progressed from 4.0 to 4.1 to 4.5. We've been able to iteratively improve the F# language design and flow out the changes and work with the community on RFCs and really make progress on the language. And I'm really happy with where this combination is. So this shift to open engineering, I mean, maybe that's a term I could use for it. We're still enterprise, we're still open source. This combination, let's just call it open engineering for this talk. It happened around 2014, 2015, and .NET has gone the same way in 2016. And I like to think we acted as inspiration for the .NET shift to this as well. And this has been really a huge success, and I'm really incredibly happy with where we are. And I think Microsoft, as the people who originated that shift, are very happy to be part of this. So let's run through some things about the ramifications of that shift. Just a couple of signals that you can pick up on. So we've got loads of pull requests have come into the F# compiler. Including, for instance, we have JetBrains contributing to the F# editing support. So that space of cooperation between what in some ways are different tooling vendors is working out. That's the magic, really, when you get cooperative spaces to do the open engineering. So you can take a look at the guide on fsharp.github.io to find out where to contribute. We have a language design process, which is to use to drive that change. Take a look at FSLang design. If you've got suggestions, you'd be one of those people feeding me sort of points of view on where the F# language design should go, then drop them in on F# language suggestions or search and vote on the ones that are there. We take the language suggestions and turn them into, we approve them in principle. They become RFCs in the FSLang design, and you can read through all the previous RFCs and comment on them and contribute new ones and then help implement them as well. So please get involved. It's a lot of fun. Quickly run through what we did in those releases. F# 4.0, I won't go through this in detail. You can kind of see the usual kind of lists of improvements and betterness. We did a lot of work on the core library. We made type providers more powerful. We did better debugging tooling, perf improvements on the compiler, etc. Just betterness. We this F-sharp 4.1 and 4.2 have been influenced by this sort of this great thing in .NET that you can use structs to get performance, increased performance. And we've been doing that through making a whole lot of unboxed options available for various F-sharp types, putting some things in the core library. And we've also solved some issues in the programming model to allow you to do these sort of large open scopes, namespace like this. And I guess I can announce the F-sharp 4.5 feature set. I mean, it'll come out officially in a blog post from Philip sometime soon, but this is what has been checked into master for delivery through those channels. So it's been interesting. We've watched the C# people go through C# 7, and they kind of dripped out this feature by feature in C# 7.0, 7.1, and 7.2. This kind of features for a zone where C# really is a very good choice, which is sort of this high-performance systems programming. So where there's pointers and sort of unmanaged memory and kind of flat memory structures for programming, say, middleware in a cloud environment. Okay, and what that added up to is actually quite a really good design, which is a really important contribution to the .NET ecosystem. And we roughly think of that as span of T and memory of T. But it's actually made up of a whole lot of other technical features like biref extension methods on structs or biref returns. And we don't need to worry about the technical details so much, but a lot of it is about pointers here, biref this and that. And making the use of flat memory arrays of struct objects sort of safer, and making the use of pointers safer. And so we decided to put this into F-sharp 4.5, partly because it is now part of it's really a .NET design, and F-sharp is a .NET language, and we absolutely had to do a good job of this as well. So I'm very happy that we've been able to land this over the last month, and it's landed in master now, and it's in good shape as a feature. And if you're into this kind of safe memory, high-performance programming, then this is a great addition you can learn and use. I'm happy with how this pointer business worked out in F-sharp. So a biref of T, which exists already, is just considered a biref where you can read or write the thing. An inref is a biref, which is an in parameter, which you can only read. And an outref is a biref, which is only an out parameter, which you only meant to write. Okay, and then we did a few other things down here, syntax and so on. And now that's done, we can start to put our attention towards F-sharp 5.0, and please get involved in that design. Okay, so openness. What does this, on the openness side, we have Christoph here who does the Ironide tooling, which is this absolutely fantastic tooling for F-sharp in VS Code. A lot of F-sharp people use that every day as their main tooling. And it uses the F-sharp compiler service. And I don't think it supports Atom anymore, I'm not sure. But anyway, it's VS Code is the main point of use. And a fantastic thing, entirely community driven apart from the F-sharp compiler service, which is that core component I talked about. Openness, I mean, this is absolutely amazing. I've mentioned this already, that F-sharp is now part of the .NET SDK itself, and that means wherever the .NET Core tooling appears in the world, then F-sharp will be a part of that tooling. And that is an absolutely fantastic result for spreading F-sharp. It's having influence inside the company at Microsoft, where I am, and if it's having influence in companies like Amazon and Google as they integrate .NET Core tooling, then F-sharp goes along for the ride. And that's absolutely fantastic. So, and the wonderful thing about shifting to open engineering and open source is you get the incredible creativity of your community. And I'm going to just mention, there are lots and lots of examples of this in the F-sharp community. If you want to see one great example of it, take a look at the F-sharp Advent calendar, where we, at the end of the year, if you're part of the F-sharp community and you want to contribute to some of the great things you've been creating during the year, then you contribute a blog entry to the F-sharp Advent calendar, and we get 50, 60 of those different blog entries coming out, and they're all really good to read. I'll mention two. One is Fable, F-sharp to JavaScript. via Fable, and this gets used to implement Ironite. It gets used for real. It's not a toy. This thing is used in applications, enterprise applications. It's used, as I said, for VS Code and other things. And I strongly recommend, if you're into the JavaScript ecosystem, that you consider taking a look at Fable. And for many people, this is their entry point to F# now, not through .NET, but through Fable and JavaScript programming. And it's very much it's packaged as a node package. You're part of the JavaScript ecosystem when you use Fable. But it's a great example of the F# community's creativity. This is a great example of not only the F# community's creativity, but also their technical excellence. The SafeStack here, SafeStack github.io, is it's a functional first stack, both for Fable on the client side and .NET Core on the server side, and F# all the way, and you can share code between these two. You have a really great rapid development process where, as you save files, it automatically repopulates your web app with the code and the server side as well. And you get to use a functional first perspective all the way through. So it's a great thing in and of itself, but the fact that it's community-driven means you get community creativity and technical excellence all the way through. So if you're a great programmer and you're looking, and you're either on the web side or the server side, and you're looking for a place where your technical excellence will be respected and where you can make a big difference in delivering a full stack to the programming world, then this is a great place to contribute and work and to learn a lot as well. Okay, I've talked about the F# compiler service, so I won't do that anymore. But okay, so open engineering. This is how we resolve this tension here. It's a tension I think the computing world is going to be continuing to have to talk about over the next 10, 20, 30 years. You know, there are still real questions that come up between enterprise and openness, but you know, these things together, you need all of these things to get the goodness at the end. Enterprise quality, openness, community, tooling, and a flourishing ecosystem, and an evolution path for going forward. And all of those things together means, again, a real source of relaxation as for people working in the F# arena. And please join us. Okay, so the next area. How are we doing for time? Okay, I've got some time here. Good, fine. Okay, so the next area of tension here, what's this going to reveal? I'll run through this fairly quickly because you've been given... Oh, no, it's a surprise. Oh, yes, a different one first. Oh, okay, well, we'll do this one instead. Right, so let's get back to the one that started the talk, the question between functional and object-oriented programming. And yeah, let's go back in time, back to the days when these were really opposing camps. I mean, there are still times when the functional and object-oriented worlds feel like they're light years apart and just coming from Venus and Mars, right? There's different planets. But on the whole, it's not like that anymore. But back then, it was when we started this kind of work. So sometimes, in some situations, when you're with functional diehards, you mention the word object, and they actually literally have this painful reaction. They go, oh yeah, something like this. And that does still happen a little bit. I mean, this example that I absolutely love is this book called Compiler Implementation with Standard ML, back from the 1990s. There are also Java versions of this, and I think a C++ version as well. And every chapter had this little tagline on it that would say, like, garbage collection, you know, removing unnecessary objects or reclaiming unnecessary memory that is no longer going to be used, or something very deadpan, totally technical deadpan, except for chapter 14, which had this tagline: object-oriented programming, object, to express a dislike or distaste for something. So the whole point of those taglines was that he could put that in on that particular chapter, and it's which was a very it was a gem that was hidden away. Okay, So what's the F-sharp approach to this? How do we not fall into this trap of just like this trap or this kind of like rejection kind of thing? I mean, some object-oriented people have the same thing with functional programming. They go, or whatever, I'm not going to touch that. Oh my God, it's hard. That must be math. Oh my, something crazy response like that, which is just, it's just not how we get a synthesis, not how we make the world a better place. So how do we do that? Well, part of it is we use a slightly different language, okay? We say we embrace object programming, and sure, objects are fine. Well, you can program with objects, no problem, okay? And we make it fit with expression-oriented typed functional paradigm, this core functional paradigm, expression-oriented typed functional paradigm, plus the ability to use objects. That's not the same thing as object orientation, okay? This is fine. This I do have a little bit of an issue with, okay? I want to draw that out a little bit more over the next few slides. So first of all, technically, let's have a look at some F-sharp objects. Here's a nice little functional object, no state in this one. We have dx and dy. We have an internal value, this d2 thing here. We have a set of, I'll run through the tags here. Inputs to the object construction here, an implicit constructor, that's the object internals and part of the constructor. These are the exported properties, and these are some exported methods down here. So there's very much this thing that things flow in at the top, it's got some internals, and things flow out through this API here for these members. That's pretty straightforward, fairly simple. It's all type inferred, runs well in .NET, interoperates, etc., etc. The language features are pretty simple. Constructed class types up here, interface types, and a thing that already C# still doesn't have, right? Object expressions, unbelievably useful. I can implement an interface here in the middle of my code. I can implement a class. I mean, underneath, you might be inheriting. There'll be a class created underneath. It's a bit like a closure or a delegate, which will subclass this thing and then add these interfaces on and so on. But you don't think of it in terms of object orientation. You just think of it as implementing a little abstraction. And it fits incredibly well with functional programming. Absolutely no problem with this whatsoever. It just fits really beautifully, and it fits very well with type inference. And it's just using this feature alone, a lot of your boilerplate C# code will just sort of disappears along the way. And so this is a nice set of features we have here. Okay, but of course, that object orientation isn't just one thing, okay? And you look at the object tradition of programming languages, and Matt's covered this, I think, some of the background to this in his keynote. You kind of have to come to object orientation as a language designer, and you have to pull it apart into lots and lots of different things. Like here we have the dot notation. Well, nobody can really complain about the dot notation, okay? We have instance members, like we saw those on the previous slide, and etc. Type-directed name resolution, that you work out what this length means based on the type of X. And etc., etc. We run through all these different features. And in a sense, as a language designer, in coming up with this synthesis, you have to take this set of features and actually have an opinion about them. And perhaps something we haven't communicated well enough over time is, what is the F-sharp opinion on object orientation? Well, that's what really this big question is. And of course, you have to make these fit with the other features you want, the functional features. So when you come to these, you kind of put them in different buckets, and you say, well, some of them make F-sharp a better API language. They're actually genuine improvements to F-sharp and make it for expressing APIs. Some of it is just like structs about implementing things efficiently. Some of it are just part of being a .NET. You're part of an interop standard, or in the context of compiling to JavaScript, you need to interoperate with JavaScript objects. And some of them just aren't needed. Okay, you don't need to suck on the whole thing just because you suck on one thing. Okay, so roughly speaking, where we stand is this. So we take this core set of features, so you take index annotation or static members or instance members or interface types and their implementations, optional arguments, and we say, sure, these are absolutely great to be using in F-sharp code. You've got to use them well. You can design badly with this set of features, but this makes F-sharp an outright better language to use this set of object-oriented features and use them well. Now, then there's a sort of second bucket of things, which is like mutable data, auto properties, patterns like idisposable, events, structs, delegates, enums, and typecasting here, which F# would still be F# without these things, okay? But we need these for various reasons. So you sort of use where necessary, use tastefully, use respectfully, and probably use sparingly. But it's still okay to use them, but just be aware that it's not core to the work. It might be around the edges of your work, okay? And then there's a set of features, which I've conveniently put in red over here, such as these large type hierarchies of things, this use of implementation inheritance in large type hierarchies, use of nulls and unchecked default, and extensive use of method overloading. That's a bit of a spectrum, but let's say overloading methods ambiguously based on type. And number of arguments. And these are, this is where you're going down the rabbit hole if you embrace this stuff too much. This is a heavy, heavy object orientation over this side, and we say probably not in F#. There are some cases where you might still use some of these things, but probably not. And then there's a set of things we just don't do. We actually don't support protected and the reason we don't support protected is because it encourages implementation inheritance and only works in the context of implementation inheritance, and I don't like that. Okay, I don't want to people to be led towards implementation inheritance, wildcard types and aspect-oriented programming, and so on. Okay, so we don't do those, not supported. So roughly speaking, love these, tolerate these, mostly avoid these, and forget all about these. Okay, and then you'll be happy and you get on with your programming life. And that's the difference now between object programming, which F# does support, and that's about succinct coding, notational convenience. C# has done a great job of being an API design language, okay? And you can do all those things in F#. So it's about API ergonomics, good naming, practical encapsulation, sensible, small, composable abstractions. This is all good in the context of object-oriented object programming with F#. And it fits well with being expression-oriented. And above all, and the most important thing of all, is it focuses on making simple things out of complex foundations, okay? So that you can, and that is often done out of delegation. You make something simple, you capture it as in your closure of things or in your object design, and you make a simple API which it delegates towards complex foundations. Okay. Object-oriented programming on the other side, it says object is going to be a single dominant paradigm that affects both all the way from your implementation all the way up through to your UML diagrams and objects absolutely everywhere. It's massive overuse of hierarchical classification, starting with the very first page of those design books. I don't know what it is about people. They just want to, once you give them the ability to hierarchically classify things, they just start classifying the entire world sort of obsessively, They start with animal and then they just continue to do that. I think it must be something cognitive that encourages that people have this natural facility to draw, to put things into buckets and then draw connections between them. Okay, so overuse of hierarchical classification. Object-oriented programming has often large abstractions with loads of failure points, okay? Loads of nulls or loads of places where things sort of don't work, okay? And in implementation inheritance, if you start with something complex and you inherit from it, then you can only make it more complex, okay? Implementation inheritance encourages the creation of complexity, okay? Because you're making complex things out of complex things. Okay, and that is the fundamental reason why I don't fully embrace object-oriented programming. Okay, at a technical level, that means you have all these functional features here, and then you have all these object features down here, and you've got to work out how they all interact. And a lot of the F# language design is about getting this right. You're getting all these tick boxes, and then making some careful limitations around the edges down the bottom. I won't go through those, but you sort of get this relatively graceful degradation. So you might need some type annotations over here, or if you use a combination of features. And the same with down here. Okay, and then some combinations it's outlawed here. We don't allow currying here and method overloading. Okay. So that is, again, a positive synthesis. There are some limitations. And sorry, that comment is from an old talk. I'm not going to be talking about this here. But there's a strong positive synthesis between those things. Okay, so in the last 15 minutes, I just want to run through a couple of slides on how we make functional programming practical so there's object orientation. I've talked about that. We go from functional to functional first programming. I think the other speakers have covered this well. So F# people love these kind of aspects of code, succinct, expressive, and so on. Some examples of code that we love. That's an F# program, nice and succinct and small. And we love our pipelines like this here. You will have seen these in other talks. We take something, we go pipe, pipe, pipe all day long, and half of F# code looks like this. We also, F# is people absolutely love their domain modeling code. So I think Scott Willashen has covered this well. We take some, a lot of F# code starts with this set of type definitions at the top of the file, which represents the domain model, and then the rest is semantics for that domain. And about half of the blog posts on the F# Advent Calendar kind of series are about sort of using F# for domain modeling and then capturing the core essence of the domain and then running through that. And so here are some examples of that. This is a sort of data structure that's coming back from a web service. And Odi in Nigeria here has a great comment about this. If your choice of data structure in your design domain is crucial when writing F# code, screw it up and you'll be walking around in circles. Nail it and your implementation will be concise, straightforward, and perhaps even trivial. And that is true in practice. Two great books I'd recommend, Domain Modeling Made Functional and Get Programming with F#. There's also a book I wrote called Expert F#. But if you're interested particularly in domain modeling and semantics, then these are great books. An area that I've been working on lately is in this use of functional programming for the view of UIs. So you have this view. This is Elmish, what's called Elmish code as part of Fable. And you have a view function, and it simply returns, depending on the values in some current model, it either returns this view or it returns this view, and this is obviously a little DSL for HTML. We have div, and a string, div, a class name container, button here with a on-click event here, which will dispatch a message called faster here, back around the loop, and another one dispatch slower there. Okay, so that's great. So you get to write these beautiful sort of functional, you might sort of a variation on functional reactive programming. Every time there's a change to the model, the view gets reevaluated. So I'm working a lot on making this real in the context of mobile app and Xamarin programming. You can look at a thing called elmish.xamarin forms, and here's what the view function looks like. If the button has been pressed, then you say label text I was pressed, and otherwise you have a button, you say press me, and then the very similar thing you dispatch around the loop here. So that's a mobile app view. And that lets you have sort of a mobile app in a single file. You have your set of messages here, which are coming back either external or from the user interface. You have your model, press here. You have your initial model, the button wasn't pressed. You have an update function. Well, we'll go to the view first. You have your view, which you've already seen. And it dispatches those messages. And then we have this update here, which when the message is pressed, the press becomes true. That's your full application code. You tie it together at the bottom in your app, and you have your mobile app in a single file. And then that could go to Android or iOS, and you can also run on Mac and WPF and other systems everywhere that Xamarin Forms is supported. It's early days yet with this. It's a community project on FS Projects in this incubation space. So if you're into mobile programming, if you've done some Xamarin, or if you've done some Android or iOS, come along and join in and and use this. It's a lot of fun. I found it incredibly simplifying for doing Xamarin and mobile programming. Okay. F# people love their composition, like this here. This is from Craig Stuntz. I asked the F# community for code that they love, and Craig sent me this one. It's not fancy, but I often get giddy smiles when people see it. They get the giggles. The top level of the compiler is exactly like you're taught. Lex, parse, bind, optimize, code gen. Uses a bit of railway-oriented programming by Scott Willashen at the end here, because these last few phases might have a failure point, and you just get that lovely pipeline down through the code. Okay, one's back on. And just to mention that a functional first approach does make a huge difference, and you can look at fsharp.org/testimonials. I'll skip this and just mention one example of this, and that is, let's see, here. We have this $3 billion unicorn company built on F#. The Jet.com was acquired by Walmart, and for a deal worth $3 billion. And they're pretty much entirely an F# shop. You can talk to Nikhil here, who used to work at Jet, about the background for their use of F# and why they chose F# and why they were able to build such an incredibly successful company on it. And it is the first unicorn built on the Azure platform. So it's, from the Microsoft perspective and a business perspective, it's absolutely huge result. It shows that Azure is ready for building incredible business value and delivering it all the way through. Okay, so the functional first of programming really does work in practice. It's functional programming is not some academic thing. You modify it to make sure it's practical, and you have functional first, and everything is great. Okay, in the last 5 minutes, I'll just talk about one more area of tension. It's a more technical area, and it's basically the tension between code and data. Back in around 2010, 2011, those of us at Microsoft Research really saw that there was a big shift going on in the world, okay, where companies had to be much more data focused, okay. This shift had been going on in sort of the database world, but suddenly it became absolutely pervasive that the working life of most programmers was no longer, it used to be the day that when you start the old joke that, okay, you guys get coding while I work out what we have to do. Okay, that in order to be a programmer, there was a whole lot of code that you wrote, you know, whatever, that was sort of generic, and then there was a problem you needed to do, and then you needed to code. But it's different these days in that data is an integral part of everybody's working life. That it's no longer about coding, it's about like, what's my data? What are we interoperating with? And that's pervasive in loads and loads of different ways. And what it means is that, you know, if you talk about one large company, these are not exact numbers, but they're just sort of scale of things. Well, for every one person working on tooling for code, there's probably 10 people working at Microsoft on tooling for data. Okay, I don't know that's a totally rough guesstimate, but that's, you know, we all think about code and Visual Studio or what other kinds of tooling the whole time, but data tooling is this vast endeavor, and of course it's vastly important. And that's all because of this. You know, we are today all, you know, we live at an incredible point in history of this information revolution. So where did that leave us from the programming language perspective? Do we just ignore that? Okay, do we just ignore this sort of tension between code and data? Well, at F# we did something about it, okay? And that was, we took the approach, we have to be able to bring information into the language in a very generic way, and we have to be able to do that at internet scale, arbitrary scale, and we have to be able to do it strongly tooled and strongly typed. And that's the fundamental thing we recognized, and we have to be able to solve this problem. And I don't think any other language has solved it as well as F# in the context of strong typing. And to do that, we had to sort of blur the lines between static and dynamic. Some people make statically typed. Everyone was trying to do this, but we actually didn't do what other people. Some people tried to make statically languages more dynamic. Some people tried to make dynamic languages more static. Instead, we changed the idea of static typing and we apply it very broadly. And that leads to this thing called F# type providers. They look just like a library, but they're actually a plug-in to your compiler and to your editor tooling, okay, that computes a space of types and methods on demand. It's like computing a .NET library on demand. Okay, so it's an adapter between data and services, and on demand you produce this .NET type system. So on-demand, scalable, compile time provision of type definitions. So if the internet, you've seen examples of F# type providers. Up the top here, people typing in code over some data source. In this case, it's a CSV, and then which has the same schema as some external data source, and you get strong IntelliSense here immediately on your data source. You've seen examples of those. I won't go through the other one. So, but what it means is this one general mechanism lets us do loads and loads of different data sources with one mechanism. All your types belong to us is what we were calling it. That's the example you've seen here, loading data from this web service and getting strong typing through to it automatically. So it's literally used this sample data as the schema. So you're drawing types from samples, and every data source you come across typically has sample data that as its documentation. And you can often just use that sample data, like the samples you get back from a GitHub Web API, for example, and use that to generate your types on demand and get your strong typing for your data source. You can do the same thing with JSON data here. We have a sample being drawn directly from a web API. Okay, and then that's the actual runtime thing. So we load here, JSON provider over that sample, and then we get strong typing over that JSON data. You can do the same thing with XML, do the same thing with SQL. There's a couple of variations on SQL here. This is using one called SQL data connection. This is actually a different type provider where you actually put your SQL here, and it gets strongly checked at compile time by talking to the database through the connection string. And so you're kind of getting strong checking for your SQL at compile time here, which is a pretty rare and very productive embedding of SQL into your language. You could do it with big data systems. We've done samples for Hadoop and Hive. You can do it with web APIs like this World Bank API here. And you can do it for entire entity graphs. It's an old sample called Freebase. You can do it for old-fashioned web services like this one here. You get, again, strong typing. My location.latitude is strongly typed there. You can even do it for interoperating with other programming languages, like the R provider, so that if you've got R installed on your system and you want to use those libraries, then you can use the R provider. Some people have said, I mean, type providers are absolutely great. I think it's a crucial problem. Here's a quote from a professor about the core idea of type providers: integrating internet-scale information services directly into the program's variable and type space. Okay, that's kind of the core idea, and it's a core idea that is necessary at this time in the development of programming languages. And what this means, by doing one thing, one mechanism, and having so many different applications of it, then there's a whole lot of things we don't need to worry about in F# anymore. I mean, we actually have to build those type providers, which is an art in itself, but we don't have to keep extending the language to interoperate with XML. We don't have to keep extending it to interoperate with JSON, or et cetera, et cetera, et cetera. We've got one mechanism that copes with loads of different integrations of data into the language. Okay. Right. So just to mention, to finish up, there are other areas where the same thing applies. I won't go through the details, but technical areas like this in the language design. We made a big contribution in the development of async programming, and again, it's a contribution to get those things to fit and to fit well. and units of measure is the same sort of thing. And I've talked about Fable and getting a win-win between these kind of systems. And this is, a proof that this sort of full stack kind of approach is a good synthesis of this kind of problem. Okay, so just to finish up, as you go through your working life, remember the Hegel. Don't try and read him. You can try and read him. If you manage to, then let me know. That's great. But remember this, that when you have opposing points of view, there is hopefully some sort of synthesis that you can find to make the world a better place. That might play out in lots and lots of different ways. I've tried to give you examples of how that applies. We do live in a world of lots of conflicting choices, ideas, techniques. Our politics is incredibly polarized today, and it's really hard to find a way through that towards a middle ground. But this idea, the synthesis from contradiction, is what applied programming language design is really about. And I encourage you, if you've got these conflicts, resolve your conflicts. If they're making you, whether that's by designing a programming language or contributing to a design or however that happens, resolve your inner conflicts, and hopefully that leaves you to a lovely state of relaxation and happiness. And thank you very much. Are we taking questions, or maybe not? No questions. Okay.